Okay, so now we are going to use the Spectrum Insight software. So I have a few example here, which is sampled from Mardi, Chile sample. So in fact, okay, just to show you. Oh, maybe I should show the browsing. So you can actually import file here. So in fact, I already imported this folder here, a bunch of Chile model. I think inside, there's a database as well. Show you previous or actually template sample, which is in Speckims. There's some tags as well. Yeah, yeah. This is FX17 with Lumo scanner. This one you can see as well. Speckim IQ. When it was taken, it was in November last year. Number of bands sampled. Yeah. Okay. There's a different timing. Anyway, yeah. So we can explore this in here. I'll just try to. Okay. Now you see here, there's a spectral plot. So in fact, for Speckim, sometimes, well, the default base of the image are mostly in RGB, meaning it's sort of the true color of it. At which wavelengths does the RGB sits? But you might want to change this if you are doing a lot more analysis in IR range. Well, for me, I always play around with it. Like for example, I just pull. See, you can see now there's bruises here. If I pull it down back, earlier where was it? Here. It's not too obvious. So yeah, just pull it, and then you can see over here there's bruises. Pull green, even better. Now you can see there's some spot here which you cannot see in red. Actually, you can see, just not too obvious. So of course you have to play around with this a lot. This is, I'd say, it's just way of viewing things. I mean, you can set up it differently as well. Yeah, so just, you know, just trying to get used to this as well. Okay, this is the part which you can play. Of course, you can look at the spectrum based on this. So you can change like this brown here, and then there's the background have this spectral signature. If I'm mistaken, you can put another one. Oh no, sorry, that's only on. Oh yeah, this one. There's another one you can put here to check the spectral reflectance of this. You can see it's almost the same, actually. And this spectral reflectance here is a bit different. So this is how you tell how different stuff is. Even this black here is different. This white here is different. See, the white is reflecting everything basically. Even this bruises is different. Oh, anyway, this is one part that you can play around. So of course you can remove this. Just remove all of it. Yeah, it's okay. I'm just gonna let it there. Okay, let me remove this. So, for analysis, as I mentioned, there's this color coordinate as well, which when you open it display this chromaticity coordinates. In fact, you can change this or this to 10 degrees. Yeah, and you can have color coordinates. See, if you play around, it's actually changed a lot. So you want to know there's a LAB value as well. There is a target, how much you want to put. Yeah, you can make a color palette actually. Yeah, there's a maximum delta E, number of colors. Okay. I'm just trying to see. Yeah, this is just axis of where the color is. So if you move around, you can see that the X here is where it changes. So it's the white is almost the center. All the L is very high. 10 degree. You can also change delta E to a few delta E's. Anyway, this is for the RGB analysis. Quite straightforward, to be honest. Yeah, there's that, and then you have this PCA. As I mentioned earlier, this actually you can increase the component. What does it mean by component? It's actually creating some sort of a few class of a, how to say it, a few component. Okay, one component means you want to have one classification. So if you have five, meaning you have five classification which you want to split item into five. Well, you can increase it as high as possible, and you can. Sorry, I just misclicked this. Yeah, you can play around with this actually. Background removalization, removing, and then you have this noise cancellation again. It's not noise reduction, not cancellation. And you can actually just wait it to calculate. It will give you a sort of component of this whole image. Well, let's wait until it's computing. Okay. Yeah, so we have five components giving out this sort of spectrum with shadows and everything. But this actually you can play with the image, sorry, with the scatter plot. So I see a few components actually almost close together. You can highlight this component using this. Just click on your mouse. You see where this is. This is a table actually. We'll put green. See. So this is a table almost have the same spectrum as this. So this is a bit the problem with PCA is actually something that looks almost the same will have the same sort of color as the background, then it will actually detect this thing. Yeah, and if you want, you can actually move this around to see. If you want all this, how to say, chili highlighted, you can see it's huge variation. That's the reason for this. It's because the color of chili is not constant. I mean, some chili might be a bit brighter than some, but they almost had this. They are almost at the same y-axis, so they look almost the same. Oh, yep. Oh, let me change the color of this. I think it's green. Right. Oh no, sorry, not this. Not green. This one. Change to red. Now you see the chili have same sort of yeah, spectrum on the image thing. Yeah, there we go. So this is basically the PCA. In fact, you can do this for a few. This is just to play around with. Let me find a calculator for. Then you can also put calculator. I should try to close this result first. Just get it back to the. This is highlighted by the PCA, but I can remove a few things because I wanted to test the index of the custom calculator. So it's NIR minus red. I'm not mistaken. Let me check the formula again. Okay, so it's NIR minus red over NIR plus red. NIR should be around 9. NIR. Let me go again. The actual value is okay. NIR is around 481. Oh, how to this one? Yes, 4. I'm sorry, 841. 87. Oh, clear. Oh, sorry, 87. No. 876. 841. Yep. Minus. Okay, red is 620 670. Okay. I'll just put bracket because okay. Divided by, actually they are the same, but instead of minus is plus. Yeah, so NIR minus red, NIR plus red, run. Yes, so yes, this is what I'm expecting to look at. So you have this heat map between -1 to 1, where the negative actually correspond to a lot more to water, or more like how to say, something wet, not too, not basically not plants, I can say, but positive, going to a positive, something correspond to quite grass or green indexes. So you can see actually that makes sense, because we can see on all the stems, it's more or less towards positive, meaning there is a correspond to a vegetation, because it's a stem, it's the wood of the vegetation. So all this thing you can see, it's already, some part of it's actually already very dry. A lot of water actually, a lot of water here. Yeah, yeah, you can see some is not too ripe, some here as well not too ripe. So but this all this thing, there's some calculation that you need to do. You actually need to do it in you actually need to know what's the wavelengths you want to look at. This is just an example of NDVI. Yeah, you can actually publish this. Use this as a let's say NDVI, save. Alright, so this is a pre-processing you can do actually as well. Say you want to do pre-processing for the same stuff again. You can change some of this as well, or you can use color map. Oh no, we're not using color. So yeah, let's just run again. I'll try again. Yep, yep, pretty much just almost the same as what we were looking at earlier. Just with some clearance of a some noise, I guess. Yeah, this is basically the calculator, so you can play around with this. This is okay. So now, yeah, this is basically the part of it which I think important to understand where to use it. But this is more of an exploring the idea of it. Can reset the RGB band again. Yeah. Okay. Now I think this most important part is actually to show how to use the training, because you actually want to train your algorithm to actually recognize chilies and everything. So of course you can also play around here if you want. How easy for you to look at the image, I guess. Let me just, yeah, I think this is the best for me because I did this before previously. Yes, okay. And here there is a few parameter that you want to look at. For example, spectral binning, or you want to, if I wouldn't really recommend you to use very high. Very high meaning you want to simplify your spectrum. It's generally not a good idea. But usually just go to the first one. You can also have cross validation, and there is also pre-processing. The same story. You have the whole thing again. But since we're just gonna use one, I'm just gonna use this noise reduction. So for this selection now, uh, you can actually select which area you don't want. For example, this I know that this is the spectrum of the background. So this, with this I can actually classify this thing as a background. I'm just gonna put this as background 01 and put it as black. Okay. There's a threshold here if you want to enable it to actually what does it do is that if there's something is almost similar to this, then it will identify it as a background. So generally you can put it very low, but you can also put it very high, provided that they all looks almost the same. But the problem with this is that the higher you put, the more similarity there will be. I mean, one mistake you are going to select everything as a background. So I can use this as a background, which I can select as black and here and background. Then I can use another one. I'm just going to do the same thing, background validation. Then I can test now. Oh, I need one more class actually. Okay, let's select this chili here, and I want to classify it just a new classification as chili 1. I'm gonna put color red. Okay, close. Now I'm gonna put this red as well. Okay, chili. Maybe another one here. Okay. Sorry, chili. Oh, yeah, validation. Now we can test. So there will be some training. You can actually see the spectral line is almost the same for red, and it's almost the same for black. There's some cross section here. Yeah, you can see. Where did it go? Earlier. Thought I saw it earlier. Yep, this is the entire image. Classification. Why there's a heat map here? Because of this background. So you can see the background is classified as background, and there's chili classified as chili. Well, to be honest, you really have to play a lot with this, because you have to add more samples. As for example, see, I can also put here this thing. as a background as well. But now this would jeopardize the entire reading as well. So not a bad idea, but also not not too good. I can say it's just preferably try to put it something else. Maybe you can put it as a background too. You don't want to mix them together, but this one you have to change it to white maybe. Okay. So let's put it. Oh, I just put a wrong name. Background 2. Change the background 2. Yep. Maybe here as well. Background 2. Then let's test again. See how it goes. Generally, the more sample you copied, the more how to say, the more sample you copied, the more accurate your sample should be. But there's also one problem, is that when you select too much, it's also going to cause some problem. This thing a bit slow. Well, I think I just saw it. It's auto saving. %, background. Let me just cancel it, not to save. Yes, I'm just going to save it later, because I want to see this first. Classification. Oh, it's not showing. Yeah. Oh, well, as I said, it's not a good idea sometimes. You can see that it's not selecting. Now all the stem is gone. And the chili, let me just go with the background. This is what the background selected. Yep. So chili, this area is the chili selected. Yeah, this all, the heat map is where all the white should be. Yeah. No, that's a bit of an issue. Well, this is more of how you put, for example, I didn't put validation. Oh, oh my God. Yeah. No, I have to repeat this whole thing again. I'm sorry. Mm. That generally happened when I didn't save properly. It's okay. We'll just go back to this. Let me just do it quick. Let me just do it real quick. Just gonna save this real quick. Okay, let me just run again. Alright. Alright. I think I saw it earlier. It looks like actually you can see this full report when you click on report. You can see all the heat map, background prediction. Oh, it's quite a lot of stuff. Let's just background. Yeah, you can change a few. Background, pretty chilly prediction. This is all the chili selected. Classification is actually a very good classification. I mean, as I mentioned, you need to have a lot of sampling, like what I just did earlier. This is actually a very quick sampling, but you can already see the result is actually quite good. I click on this. The background selection didn't select anything but the background. The chili selection only selects chili, except this part, this bruises here. Actually, this is also we need to train it on detecting the bruises. Now you can see the selection of the chili. Yeah, looks good. Okay. Now when you have all this, what you want to do is that you actually want to save this. I mean, keep it as a publish. Yeah, publish is that as an application, basically. Well, just before we go on that, in fact, you can actually add more samples, like here. So I add that to training. Now you have another one. You can also train this to become part of the model. So whenever you train more, meaning you have more sampling like this here, then the more you add, the more you get accuracy. But as I mentioned, there's one problem as well. The more you add, sometimes can lead to false claim, meaning your model is too complex that it might start to consider other things as part of your subject, part of your result. Yeah, so when you have all this finished, you can actually publish this as an application. So when you publish this as a publication, let me just say chili app. You can save this. Now it's already installed in the apps view. I can just go here and find it here. I need to install it though. Okay. Well, this one as well, the one the calculation I just did earlier. Let's just install it. Okay. Now you can go to Explore and start applying this application. Run application, Chili apps. See? Now you have it. Or you can run this on this. See? So this is generally how to use it. Quite simple. In fact, this is how useful it is. Once you click, when you create a lot of applications, so next time you want to explore, you just click on the. Let's say if I have this, yeah. Maybe I can use this. Put in explore. Yep. I can try to run it again. Run. Yes. So you see the application works fine. So generally what you want to do is that this is the thing that you want to do. You want to train all your sample first, like what I just did. What I'm doing is just a sample, so I'm doing a very simplistic study, which I just classify almost the same stuff. But when you do want to use a real training model, for example, this chili, I can pass this application to you, and I reckon if you take a sample that looks using the same chili like this, and you can run again, like with this, I can show you. It even work with other. Sorry, not Explorer. Even works with others as well. This might. Sorry, this might be a bit hard because there's other stuff behind here. But the condition is almost the same. They are all chilly at the end of the day. I can run again. Now you can see it works. It's this one. Yep, this still works actually. Yes. Simple. Yeah. So that's basically it. I mean, this that's the how to use all this software, Specum Insight. So I think that's about it. Thanks.